Okay, chapter 6.5 is about inverse trigonometric functions, and first thing I want to deal with these functions, it's inverse sine, inverse cosine, inverse secant, inverse cosecant, inverse tangent, inverse cotangent. First thing I want to bring to your attention is these aren't the same as reciprocals. So if I were to see, for example, sine of x, the negative first power, that's 1 over sine of x, which is the same as cosecant of x. That's not the same as inverse sine of x. So inverse sine of x, for example, inverse sine of a half, it's asking what angle makes this sine value. So what angle in the unit circle has a half angle, or half value, which would be pi over 6. All right. It's also true at 5 pi over 6. It happens again and again and again with coterminal angles. If you look at the second page, though, the ranges of these, we're looking for the answer between negative pi over 2 and pi over 2 for these four, between 0 and pi for these two. All right, so I would only take this one here is the one I'd want if I'm doing inverse sine. All right, and the domain of these is what's important mainly if we're trying to evaluate. So if I'm trying to do inverse sine or inverse cosine of anything, that anything has to be between negative 1 and 1. Inverse sine of a half is possible because it's between negative 1 and 1. Inverse sine of negative 1 is negative pi over 2. That's possible because it's negative 1 equals x. If I try to do inverse sine of 2, that does not exist, undefined something. Sine cannot equal a number bigger than 1 or less than negative 1. It's between that. Imagine the sine graph that we did back a while back. Y equals sine of x. That graph went up to 1, down to negative 1, and started at 0, went up to the top, went back to 0, down to the bottom, back up to 0. It went like that, and it stays in between negative 1 and 1. So what we're doing is we're inputting this number and we're outputting that number. That's what the inverse function is. What angle creates a sine value of this, or what angle creates a sine value of that? So if we have a sine value of 2, that's not possible, so it's undefined. The same argument goes for cosine, sine, and cosine of the same graph, just one slid over from the other. All right. As far as secant and cosecant is concerned, if you consider those graphs, they're being the reciprocals of sine and cosine. They start at 1 and go up, or start at negative 1 and go down. So every number less than or equal to negative 1 or greater than or equal to positive 1 is possible for a secant or cosecant. So if you do inverse secant, let's say of 2, you'd find out where secant equals 2. That's the same place cosine is equal to a half. So again, that's possible. Tangent and cotangent, their graphs between asymptotes, of course, go like that. Every real number is hit. So the input for inverse tangent and inverse cotangent is any real number. So if it says inverse tangent of 5,847, it has an answer. All right, if it says inverse tangent of 0, it has an answer. Inverse tangent of negative 1 has an answer, and so on. So these are easy to get along with these. Any number you can put in. All right. As far as the ranges, the outputs, the answers themselves, these four trig functions are between negative and positive pi over 2. And let me show you how to handle this. If, let's say I'm doing inverse sine of, let's go negative square root of 3 over 2. Okay. If I find this on the sheet, and hopefully we've got this memorized already, but if you don't, if you look on the sheet, on the sine column, you'll find square root of 3 over 2 happens at negative square root of 3 over 2. It happens at 4 pi over 3 and 5 pi over 3. Those are the two values it happens at. If I subtract 6 or 2 pi from each of those, so subtract 6 pi over 3 from each of those, this makes negative 2 pi over 3. This makes negative pi over 3. That's the answer, negative pi over 3. That's between negative pi over 2 and positive pi over 2. Negative, if we put this over 12, 6 pi over 12. Negative pi over 3 is negative 4 pi over 12. So you can see that's between those. If you always go to 12ths, it's very easy to see what's between what. So you find the answers on the sheet, but then you got to subtract 2 pi away. 2 pi in the form of 6 pi over 3 to get the right one. So keep that in mind that if we're doing an inverse trig function, we're trying to evaluate it, we might have to modify the answer slightly. We won't necessarily get the answer on our sheet. So with that in mind, these two right here, cosine and secant, between 0 and pi, basically that takes in every possible sign. So if we take a look at these four, sine, cosecant, tangent, cotangent are all positive in the first quadrant. Sine and cosecant are both positive in the second quadrant also. They're both negative in these. Tangent and cotangent are negative down here. So just to keep it all the same, they've made it so everything's down here. So sine and cosecant and tangent and cotangent are all negative down here. So negative pi over 2, 0, pi over 2, every sign of all four of these trig functions, positive or negative, are taken in within those two quadrants. Where the other two, cosine and secant, are also positive in this one, but they're negative over here. They're both positive in this one, so that's why cosine and secant have a different range. Again, we're allowing for every sign of the answer, positive or negative, to show up when we do that. So, first thing I'm going to deal with today, just straight evaluation. When it says find the exact value, I'm going to want it radian value. When it says exact, that means it has an exact answer. It will be on your sheet, or again, you can modify, subtract or add 2 pi to get within the sheet. I suppose you have to subtract 2 pi is what would happen. Because again, if we're down in the third and fourth quadrant, we'd want the fourth quadrant one, just subtract 2 pi from that to get the right answer. So, inverse tangent of positive square root of 3 over 3, that's going to be in the first quadrant. We look for where sine or tangent equals the square root of 3 over 3, and again, if you look on your sheet, under the tangent column, you got 0, followed by pi over 6, followed by pi over 4, followed by pi over 3, followed by pi over 2. All right. On the tangent column, tangent of 0 is 0, tangent of pi over 6 square root of 3 over 3. Tangent of pi over 4 is 1, tangent of pi over 3 is the square root of 3, and tangent of pi over 2 is undefined. That's what the sheet says. So if it says inverse tangent of square root of 3 over 3, I find that, I look there, and that's the answer. Okay, so again, it's asking where does tangent equal this, what angle does it equal it at, and that's what you're looking for. Same deal for inverse cosine of square root of 2 over 2. Again, if I have my sheet, here's my cosine column, and I've got 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, and so on. All right, cosine of this is 1, then the square root of 3 over 2, then square root of 2 over 2, then 1/2, 0, negative 1/2, negative square root of 2 over 2, and so on. All right, all we care about is numbers going through pi, which I didn't go far enough down, but if I continued on, 5 pi over 6 is next. That's negative square root of 3 over 2, and pi is last, negative 1. So these are all the exact values of cosine I can actually find an answer for. And again, it's asking me for the inverse cosine of negative square root of 2 over 2. It's right there. This is between 0 and pi, which is the inverse cosine range. So we're going to take the 3 pi over 4 answer. All right, and that's how you do it. The answer is between 0 and pi over 2. And let me just bring the sheet up real quick just to highlight this for you. Because the ones that are tricky are the sine, cosine, tangent, and cotangent. Wrong class. There it is. All right. So formulas and conversion tables, the smaller one. There we go. So I'm going to make that smaller so we can see everything I want to look at. All right. The answers between 0 and pi over 2 are right here. So between 0 and pi over 2 is this set of numbers, and the other ones, negative pi over 2 to 0, are going to be down here. So if I'm doing an inverse sine, let's say it says inverse sine not going to be right over there, is it? Inverse sine, let's say, of negative square root of 3 over 2. That one, all right? So we go back over here, and we find the sine column, we find negative square root of 3 over 2, which is right here, which happens at 5 power 3. That's the answer I'm looking for, but that's the one that's too big. It's in the wrong, it's in the fourth quadrant. It's not the negative angle that I'm looking for. So that's when I'm going to go here and say it's 5 pi over 3, but I need to subtract 2 pi from it. And again, 2 pi in disguise as the common denominator, 2 pi version 6 pi over 3. So negative pi over 3 gives me that answer. All right? Do the same with tangent, cotangent, whatever. So if you're one of those four where the answer is between negative pi over 2 and 0, and you know that because it's negative, find the fourth quadrant answer and then subtract 2 pi from it. That'll get you the fourth quadrant answer with the negative angle version of that. That's what you're trying to do. So again, the first set of homework questions is going to be like this. They're just going to say, find the exact value. Your sheet's going to be useful. Again, the trickiest part is that you're going to get one of those four secant, cosecant, or sorry, secant, cosecant, sine, tangent, cotangent, those four, where the answer's in the fourth quadrant. They want the negative angle version instead of the positive one that's on your sheet. So just subtract 2 pi when that happens, you're in good shape.